Hello students, I would like to introduce for you the course CS390, Principles of Programming Languages. So this presentation is mostly for online students um, and I just want to go through the important aspects and pieces of that course. So first in the content you can find here the syllabus. This is probably where you should start looking at the prerequisites, outcomes, but really um, this table here is really the most important because it kind of recapitulates and synthesizes the complete course along with the weeks it's taught at and the book's reference for each of the portions of the course. So as you can see, there are two parts of this course, and I'll apologize, the resolution is not great. You can find a full resolution here in the link below. Um, there are two parts to this course. The first part is about exploring different paradigms of programming languages, and the second part is going into the principles and the theory behind those programming languages. So these two parts really go together. This course is really the combination of an exploration of all the paradigms. Right now you've been focusing mostly on imperative and even actually on object-oriented paradigm. And we want to explore other ways of approaching computation that are all Turing complete. They are all equivalent. They all have the same computational power, and this is something that you'd explore in a subsequent course in computation theory. But they approach the question of computation and they use differently, and they use very different constructs, right? So the idea is to first explore very concretely those constructs through different programming languages like C, C++, Prolog, and Clojure for the functional. And then once this exploration is done, to look at what are the theoretical foundation for any programming languages. And we'll see that they're actually more or less the same, right? So you have the syllabus here, and below there is the weight for each graded assignments. So you'll notice that this is a course that is pretty heavy on assignments, not as heavy in exam. There's only one final exam, no midterm exam. And you have here all the assignment and exam policy. This is important. So if we go into the content, you'll see here the two parts, the part one on paradigms and the part two, each with their topics. So the part one on paradigms, the topics are going to be basically one topic per paradigm. We start with an overview on what we mean by paradigms and what are they, what is a low level versus high level, imperative versus declarative, and so forth. It's a fairly short topic. And then we go basically from topic 2 to topic 6, kind of in order of low level to high level, right? So there is kind of a progression here from the lowest level, the closest to machine language, starting with assembly language. Then we move on to procedural, which is a bit higher level, and then object-oriented a bit higher level, and so forth. The two last ones are kind of at the same level. Logic programming and functional are both part of what we call declarative paradigm. Although it used to be the other way around, because one could argue that logic programming is actually a little bit higher level than functional programming, and that would make sense. The reason I inverted them is because of what comes as an assignment for the part two. So the part two really goes back, like I said, to the foundations, looking at what is a grammar, what is syntax, and how do we parse or analyze a programming language, how we define a programming language from scratch, how a compiler works, and how it actually is able to translate programming language into machine language, and then the idea of the semantics of a programming language, name, environment, memory management, and so forth. And all of those things, all of those aspects are actually common to any paradigm. They all have these constructs that they need. They're just going to use them differently. Now, this part is very theoretical, and it's very important because a lot of things that we see in this part two, actually even in the part one, when we look concretely at some of the languages, is going to be reused in some subsequent courses. So this is a very foundational and important courses for other courses mostly for computation theory, but also for other courses that you'll have in the future. So because this is very theoretical, but we really want you to have a grasp on how this impacts concretely how we analyze and interpret any program. The idea of the assignment for the part 2, which is really one assignment, one single assignment for this whole second part of the course, is to guide you through building your own interpreter, where you're going to be able to take any kind of little program in a made-up language that you're going to create yourself. Okay, you're going to create your own grammar for your own language, and you're going to then create your own interpreter, your own little program that is going to be able to interpret and execute that program, right? So from in some sense going from just pure text to machine instructions, and you're going to do that translation. Now, in our world, it's not going to be pure text. We're going to benefit from some constructs that exist in functional programming that actually make the idea of interpretation much easier. Those constructs are like the fact that we use prefixed operations and nested sequences, but all of that you'll learn when you learn in part 1 about closure. And that's why we end with closure as an example for the functional paradigm. I forgot to mention that for each paradigm we have one typical program that we're going to use, right? Assembly for low level, C for procedural, C++ so that you have a change from Java and explore other aspects of object-oriented paradigm for object-oriented, Prolog for logic programming, and Closure for functional programming. The choice of Closure is really based on the fact that it's one of the most, it's probably the most, maybe the most, one of the most popular functional programming language used today. It's also based on JVM, so it's very easy to integrate with Java, which makes it actually a good choice for development. And the other reason is that it actually is a really good language to work on this assignment, this interpreter assignment. So the idea of this interpreter assignment is really to transform the theory of part 2 into practice and actually see concretely how it works and be able to say at the end, I was able to build my own language, to build the grammar, the theory behind my own language, and then to build an interpreter that was able to transform that language into concrete executable statements. Okay, so that's kind of a summary of this course. It is a difficult course because it's dense and heavy, combine a lot of things, a lot of new material. The programs you're going to have to build them from scratch for the most part. For the part 2, because this assignment is harder, will guide you through it. And actually, the assignment of topic 6 is going to include some kind of notions that already are going to help you build up toward the part 2 assignment, the interpreter. And then within the part 2 assignment, there will be some steps to guide you so that the instructor can give you some feedback and to avoid leaving you completely in the dark, because it is a harder assignment. But most of the little assignments for topic 2 to topic 5 are fairly small and easy, but you do have to build them from scratch. And so it is a lot of work, and we are aware of that. We have to put a lot of things in one course, but we hope you'll enjoy it and you're able to appreciate the incredible richness and variety of approach to computation from C to Prolog, and how they can be very, very different, but all serve some purpose and have some advantages for some specific objective or context. For each of those topics, you will have very detailed instructions on how to set up the environment for the language. This one is a bit particular because it's kind of made up within Regis, this model assembler, but you have very detailed instructions here. You have very detailed instructions here, tutorial on how to set up C on Windows and Mac. And same thing for C++ here. and for Prolog. So for each of those languages, you have installation tutorial that guide you through the process, whether you're on Windows and Mac. And this is exactly the same as well for Clojure, right? So you should have everything you need, and don't hesitate to reach out to your instructor if you need anything else.